Hello guys, this is Siva Parvathi. Today we are going to learn identifiers, variables, keywords and operators. Let's begin. Identifiers are the names which are used for variables, classes, functions and objects. The rules to create identifiers are: do not use reserved keywords. What are reserved keywords? We know in my coming slides. And Python is a case sensitive. If we change uppercase to lowercase or lowercase to uppercase, the machine do not understand. And do not begin the name with number or any kind of special characters. We can use only special character is underscore, and that too do not begin with the name with the underscore. We can only use the underscore in between the name. There only one kind of names which begin with underscore are constructors. Here some of the examples of the names of identifiers and some of the examples which we do not create the names of the identifiers. Here variable is a memory location which is used to store some kind of data or value. We define variable names are unique because to differentiate the memory location. If we create the same variable name in a program, the system does not differentiate which memory location to access and which value to retrieve. So that we had to create the variable names uniquely. The rules of creation of the variable name is same as the identifiers. We do not need to declare variable before using it. In Python, we simply assign a value to variable and it will exist in memory. We do not have to predefine the type of the variable. In Python, this will handle internally according to the type of the value we assign to variable. The Python keywords are known as reserved words, which has special meaning and special functionalities in language. Here, there are total 35 Python keywords. Actually, async and await do not considered as keywords in programming language because async and await are used in CPU functionalities, not in the programming language. By excluding those two keywords, we have totally 33 reserved words. In Python, constants are the Python and any functional language, constants are the fixed values which we assign to variables. Many programming languages, the indentation are lever basis, whereas Python uses white spaces as their indentation. Generally, we use 4 white spaces as indentation. In Python, memory location, we use it to say as IDs. These IDs helps to map values to variables. Same memory location means it has same ID to the same value with the different variables. By seeing the example, x equals to 10, whereas y equals to 10. Both x and y has the same value. So, both the variables are having same memory location. In Python, the memory was stored as constant value. It maps to the variable. There are many kind of operators in Python such as arithmetic, assignment, comparison, logical, identity, membership and bitwise operators. Operators are used to perform operations on variables and values. The arithmetic operators are used with numerical values to perform common mathematical operations such as addition, subtraction, multiplication, division, modular, exponent and floor division. Addition is sum of two numbers, subtraction is a subtraction of two numbers, multiplication is multiply of two numbers, whereas division as it results the quotient value, modular results the remainder, exponent is the power, floor division results integer. Assignment operators are used to assign values to variables. Here, y equals to a plus b. Here we are assigning a plus b value to y. Like that, plus equals to, minus equals to, star equals to, division equals to, modular equals to, exponent equals to, floor division equals to. We are assigning some value to some variable. Comparison operators are used to compare two values. Here we have less than, greater than, less than equals to, greater than equals to, and not equals to. These comparison operators used to compare two values which results either true or false. Logical operators are used to combine conditional statements. Logical operators contains and, or, and not. It is used to combine conditional statements and it results either true or false. Logical and returns true when both the conditions are true. Here, 5 less than 2 is a false and 5 greater than 3 is a true. So it returns false. Logical or returns true when one of the condition is true. Here 5 less than 2 is a false condition and 5 greater than 3 is a true condition. So it results true. Logical not, it gives opposite to the condition. 5 less than 2 is a false. So it results true. Special operators. The identity and membership operators are known as special operators. Identity operators are used to compare the objects. Is and is not are the identity operators. It returns true if two variable points the same object and false otherwise. Is not is opposite to the is. So if two variables point to the same object, it returns false, otherwise true. Membership operators are used to test if a variable is present in an object or not. Variable or sequence is present in an object or not. In and not in are the membership operators. In checks whether a value is found in the sequence or not. If it is found in the sequence, it returns true. Otherwise, it returns false. Not in is checks whether the value is not found in the sequence or not. If the value is not found in the sequence, it returns true, otherwise false. Not in operator is completely opposite to the in operator. Bitwise operators are used to compare binary values. Bitwise and, bitwise or, bitwise XOR, bitwise ones complement, left shift and right shift. Here the example is bitwise AND operation. The binary value of 2 is 0, 0, 1, 0 and the binary value for 6 is 0, 1, 1, 0 on basis of 8421 series. AND operation returns 1 when both bits are 1. If any one of the bit is 0, it returns 0. Here, first bit, comparing of the first bit, 0, 0, so it returns 0. Second, 1, 1, so it returns 1. Third bit, 0, 1, so it returns 0, 0, 0, it returns 0. The value for 0, 0, 1, 0 is 2. Bitwise AND operation for 2 and 6 is 2. Here we perform bitwise OR, XOR, complement, left shift and right shift for number 2 and 6. Here the bitwise OR operation for 2 and 6. Bitwise OR operator returns 1 if any one of the bit is 1. First bit 0, 0. So it returns 0. 1, 1. It returns 1. 0, 1. It returns 1. 0, 0, 0. The bitwise OR operation for 2 and 6 is 6. XOR operation. Bitwise XOR operation returns when odd number of bits is 1. If odd number of any bits are 1, then it returns 1. For example, the first bit 0, 0, 0, second 1, 1. It is even. 1, 1, 2 ones. So it returns 0. Third bit 1, 0. Only 1 exists. Only 1, 1 exists. So it returns 1, 0, 0, 0. The bitwise XOR operation for 2 and 6 is 4. Complement. Complement is nothing but we exchange the values. In zeros place we put ones and in ones place we put zeros. So 2 complement is 13. Here the value for 13 is here. Whereas left shift of value 6 by 2 bits. Here 2 represent how many bits we have to left shift it. That means this is the value of 6. We are shifting 2 bits 0 and 1 to the left side so that we are ignoring those 2 bits and we are resulting last 2 bits 1 0 here. For 8421 series we are adding another 2 zeros which results 8 and right shift for 6 by 2 bits. Here we are ignoring right side 2 bits and we are resulting left side 2 bits 0 1 and we are adding 2 zeros for the sequence. It results 4. Left shift of 6 by 2 bits is 8. Right shift of 6 by 2 bits is 4. Thank you for watching. Don't forget to like, share and subscribe to my channel. See you on my next videos.